However, we physicists say that the universe was created in a Big Bang 13.7 billion years ago, but then the question is, why did it bang? What set off the bang? For as long as we've been studying science and the history of our universe, the Big Bang has been the explanation for it all. There have been hundreds of studies, thousands of scientists have worked on the research. From what data has always said, the Big Bang has been the leading theory that proved how the universe was made. That energy is dark energy. There is an energy source even bigger than galactic, and dark energy is the energy of the Big Bang. It is the anti-gravitational force that's creating the expanding universe. But science today is a lot different than what it was back in the day, and with technological improvements come new theories. More often than not, we find out that things we believe to be 100% true are far from it, and, well, it might have just happened again. Michio Kaku is finally talking about it. The Big Bang has officially been debunked as the James Webb telescope has detected 750 new galaxies, and they are nothing like what they should be. Join us as we dig deeper into what the James Webb telescope found and how it changes everything we thought about the way the universe came into being. At first glance, the images of the new galaxies taken by the JWST look absolutely breathtaking. In a good way, you can see hundreds of galaxies all in the same frame, and the sheer power in the photos is something you just can't ignore. But that's what things look like to the average person. For researchers, things are the total opposite. These pictures are surprising to say the least. They don't match what scientists thought they would see based on their theories. In fact, they are seeing way more galaxies than expected, and these galaxies are different in some surprising ways. They are smooth, smaller than imagined, and really old. All these surprises are causing a bit of a panic among the scientists. One paper even starts with the word panic in its title, so you know things are serious. The galaxies look nothing like what they are supposed to. Scientists have put forward the Big Bang theory as the leading explanation for the origins of our vast universe. According to this theory, around 14 billion years ago, the universe came into existence through some sort of mysterious cosmic event. It's the ultimate birth story of the cosmos. The surprising nature of the images captured by the James Webb Space Telescope has challenged scientists' understanding of the universe's origins. The hypothesis that these images directly contradict is the Big Bang hypothesis, which has long been regarded as an unquestionable truth by the majority of cosmological theorists. These galaxies appear to be too small, too smooth, too old, and too numerous when compared to the predictions of the Big Bang hypothesis. The small size of the observed galaxies entirely contradicts the expected behavior in an expanding universe. According to the hypothesis, as the universe expands, objects should appear larger with increasing distance. Yet, the JWST images show galaxies that are 2 to 3 times smaller than similar galaxies observed using the Hubble Space Telescope. This discrepancy challenges the notion of an expanding universe. Our universe expanding, we don't actually envision that the universe is expanding into some pre-existing container. There's also the fact that the smoothness of these galaxies is totally unexpected. The Big Bang theory suggests that galaxies should exhibit irregularities and variations in their structures due to the dynamics of their formation and evolution. However, the JWST images reveal galaxies that appear unusually smooth, lacking the expected level of complexity and roughness, which is what you'd normally expect to see in the images. The age of the observed galaxies also seems to be incredibly strange here. The JWST observations indicate the presence of galaxies that appear to be unexpectedly old. This challenges the expected timeline of galaxy formation and evolution within the framework of the Big Bang theory. Plus, there's also the fact that the abundance of observed galaxies is a lot higher than what it was supposed to be. The Big Bang hypothesis predicts a certain distribution and density of galaxies based on the expansion and evolution of the universe, but the JWST images show a massive number of galaxies, which raises questions about the accuracy of the predictions made by the hypothesis. According to the Big Bang theory, at the very beginning of the universe, all matter, energy, and the building blocks of the cosmos were compressed into an extremely tiny and highly concentrated point. This point is called a singularity. This is a point where infinite density exists. When we say infinite density, we mean that the matter and energy within this singularity were squeezed together to such an extent that their density reached an infinitely high value. The concept of a singularity comes from our current understanding of the laws of physics, particularly the equations of general relativity proposed by Albert Einstein. Within the singularity, all the matter and energy in the universe existed in an extraordinarily compressed form. The extreme density implies that an enormous amount of mass and energy was concentrated within an infinitesimally small space. While the space isn't much of a problem here, when there's so much pressure and density, you've got unimaginable heat. The temperature within the singularity would exceed any temperature that can be observed or reproduced in our current understanding of the universe. The energy stored within this hot, dense point was the seed from which the entire universe would unfold. That's why the singularity marked the beginning of the universe as we know it. It was the origin from which everything in our cosmos came. After the initial singularity, the universe started the journey of expansion and inflation. This process occurred over the course of approximately 13.7 billion years, shaping the universe as we know it today. The expansion of the universe started with an extraordinary burst of rapid expansion known as cosmic inflation. During this phase, the universe expanded at an unimaginable rate, far exceeding the speed of light. It's like the fabric of space itself was stretching and stretching, taking everything within it along for the ride. Cosmic inflation played a massive role in shaping the large-scale structure of the universe. It smoothed out irregularities, homogenized the distribution of matter and energy, and set the stage for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of expansion gradually slowed down. But with this information, it's important to note that even though the initial period of cosmic inflation ended, the universe continued to expand at a measurable rate. This ongoing expansion is known as the expansion of the universe or cosmic expansion. Scientists have observed the effects of this expansion through various observations, such as the redshift of light from distant galaxies. The redshift indicates that as the universe expands, light waves get stretched and shifted towards longer wavelengths, shifting them towards the red end of the spectrum. While the expansion was happening, we basically had all the stuff that makes up our universe squeezed into an incredibly small volume. It was clear that matter cannot survive in space like this, so something had to give. As the universe expanded and cooled down, transformations took place. Particles such as protons, neutrons, and electrons began to interact with light and energy in their surroundings. These interactions played a pivotal role in shaping the formation of matter in the universe. During the first few minutes after the Big Bang, there was a process called nucleosynthesis. This process involved the creation of lightweight elements like hydrogen and helium. The extreme temperatures and conditions during this phase allowed for the fusion of protons and neutrons to form these simple atomic building blocks. Hydrogen, the simplest and most abundant element in the universe, was formed primarily during this early period. Helium, the second most abundant element, also emerged during this time. These elements were instrumental in setting the stage for the formation of stars, galaxies, and more complex elements that would come later in cosmic history. The synthesis of these elemental building blocks was a significant milestone in the evolution of the universe. From a primordial sea of particles and energy, the early universe transitioned into a state where matter actually began to take shape. This process laid the foundation for the rich diversity of matter and the vast cosmic structures that eventually came into being. Now, the Big Bang theory might seem like wordplay, but it is supported by a lot of compelling evidence. The Big Bang was an interesting event, but not the first event in the totality of reality. One of the most significant pieces of evidence for the Big Bang theory is the discovery of the cosmic microwave background, CMB. The CMB is a faint radiation that fills the entire universe and represents the afterglow of the Big Bang. This cosmic radiation was first detected in 1965 and has since been studied extensively. The characteristics of the CMB align closely with the predictions made by the Big Bang theory, providing strong confirmation of its validity. The observed pattern of the CMB radiation, including its uniformity and temperature distribution, supports the idea that the universe was once in an extremely hot and dense state before undergoing expansion, which, as we've discussed earlier on in the video, was one of the main things that happened during the Big Bang. The presence of the CMB provides a remarkable glimpse into the early stages of the universe, serving as a direct echo of the initial moments following the Big Bang. Its discovery and subsequent analysis have played a crucial role in cementing the Big Bang Theory as the perfect explanation for the origins of the cosmos. In addition to the CMB, other lines of evidence further prove the Big Bang Theory. You've got things like the observations of the redshift of light from distant galaxies that provide evidence of the expanding universe, too. The observation that galaxies are moving away from one another in all directions suggests that the universe is continuously expanding, as predicted by the theory. The abundance of light elements, such as hydrogen and helium, found throughout the cosmos is also consistent with the predictions of the Big Bang Theory. But not just that, the large-scale distribution of galaxies, which is something that was revealed through astronomical surveys, matches the predicted patterns emerging from the Big Bang. And so, with these multiple lines of evidence coming together, scientists have gained a comprehensive understanding of the universe's origins and evolution. Nevertheless, as technology advances and new observations are made, scientific theories are constantly refined. The James Webb Space Telescope has brought new challenges to our current understanding. The unexpected findings it has provided are prompting scientists to re-evaluate their models and theories, exploring new possibilities and avenues of research. This process of refinement and exploration is a fundamental aspect of scientific progress. The pursuit of knowledge about the cosmos is an ongoing journey, and each new discovery adds depth to our understanding of the universe and its origins.